inaugural our quantum is 0. AICTE mission knowledge have together come up with a model below, and that is one thing that we can try to look at. So, okay. So I'm sorry, kindly bear, nothing much can be done. So just for some time after that, I am so there are some here. So let some let's just bear with me for some time. Then the others will see. This program is basically being conducted from the 7 academies of electronics and ICT academies at IITs and NITs. So we have IIIT Guwahati, and we have activity partner. We have several representatives. We have we joined the guys for there. We have the chief of AICTE Academy also being solved. So let's begin. So these solved. Let's begin your issues for audio issues. So I will just try to yeah, okay. So let me Satyendra, can you take over?
Yeah, Dr. Pilli, I can take over, not a problem. But he can introduce about the program. Satyendra, are you there?
Yes, sir, I'm there, but I'm handling other issues that regarding the joining and all.
Okay, so Dr. Pilli, let me go ahead, no problem.
Yes.
Yeah, I hope
yes,
I'm audible to all speakers
yes,
and participants. Yeah. So good afternoon, everybody, especially our esteemed speakers who have been actually supporting us for last 4 to 5 programs, and there are still 4 more or 5 more to go. We are gratefully remembering them and welcome them here. Dr. Ashwath, Dr. Mustafiz Rahman, Dr. Kanhaiya Pandey, and many others who are there, who are not here. We gratefully remember them, thank them right at the outset of this program. This program is the 4th in the series today. We actually apologize. Our coordinator is on an official duty to IIIT quota, and he may have some issues in networking. Thanks to both the coordinators, the principal coordinator, Dr. E.S. Pilli, Dr. Satyen Chauhan, and other co-principal coordinators, Dr. Shivansh, and at other academies, they might join soon that way. So I take this opportunity to apprise you, as you know, but I still repeat our commitment that if you complete at least 5 courses from Quantum series, we will be happy to award you PG certification additionally to what certification you get for other programs that way. So there is just a small appraisal for that for you. This is in general applicable where AICTE has given us a mandate. All the institutes across the country a mandate to initiate minors and honors in emerging areas. No addition approval is required by any institute. They can start with approval in their own governing body or any academic body that way. The identified areas by AICTE are many, and these are the areas which they have identified: quantum technologies, website design, AI machine learning, and so on and so forth, which are very emerging areas. There is a letter by Professor Sitaram about how can we go about it and what vision AICTE carries in support of those initiation of minors and honors, which is comprising of 6 to 8 courses along with the core UG degree, core BTech degree. So they say that I think I'm missing one of the letters part. So they say that a student can take 6 to 8 subjects, and this will he has to accumulate about 18 credits to be eligible for award of minor and honors in any specific area. We actually thank IBM and spearheaded by this campaign by Dr. Mani Madhukar, Dr. Venkat Subramaniam, and we also thank AICTE and DST for giving us their all support for carrying on this mission under the National Quantum Mission. So this is what the letter says from AICTE, that the teachers who are teaching the core courses, they can actually take up the role of teaching the kind of emerging area topics leading to honors and minors if they have gone through their own training of 10 credits through MOOC or some other kind of you can say portals, where any other government portal is also mentioned, and we happen to be the AICTE academies happen to be government funded projects from the Ministry of Electronics and IT, so we are eligible to actually support that way. So instead of 10 credits, we have taken up that if you complete 5 courses, we'll be happy to award you that. You can approach any academy you are registered with, and after completing 5 programs, and we'll be happy to award you that PG certification. This is the list of second column contains the list of courses AICTE has proposed, which honors and minors could actually do that. Mr. Ramesh and Geeta, please unmute one of the participants who have raised their hands. The last column contains what we are actually the offering that way. So we are offering all parallel courses to the proposed courses. This is 4th in series, many more to come, and we still remember IBM for great support that they are. We are actually accompanying. They are accompanying all the process, whole delivery, and the kind of scheduling that way. And Dr. Madhi Madhukarji, mainly the person of contact for that part. And we have speakers today itself, Dr. Rahman, Dr. Ashwath, to carry us along with that journey that way. Lastly, I will thank Dr. N.P. Padisab, our director, for giving us the kind of freedom and the motivation to carry on with these kind of programs, initiating such kind of efforts along with the other organizations and industry that way. So I take rest here to let the proceedings going on. I would request Dr. Pilli to apprise us something what he has in his hands to apprise you beforehand the first keynote starts, and we'll request each of our co-principal coordinators at different academies to say a few words. So if Dr. Pilli is ready, he can take over.
Yes, sir. Yes, sir. Yeah, I think my audio is clear now. I connected on the wired network.
Yes. Very well.
Thank you so much. And thank you, Saula, sir, for briefing us. And the good news is, yeah, I think others are able to hear. Bharat Swanis, please check. Please check. It's not my problem now. It's audience problem. Please, if you're not able to hear, please check. Yeah, thank you so much. It's a joy to be here again, and you'll be happy to hear my voice now fully clear. So welcome back, and thank you so much for joining back.
There is some hitch in the audio again, Dr. Pilli.
1,300 people. 1,300 people have already registered. So thank you so much for the great response. And a few of them are struggling, but we'll try to keep it happy. Keep you happy. Please join. Request the others who are not able to join. Maybe some issue in WebEx. Dr. Satyendra is helping. Our technical team is helping. But in case the YouTube link is there, request them to please join there. So that they can follow the proceedings. By tomorrow, we will address these issues. So I welcome Dr. Kanaya Pandey from IIT Guwahati, our joint principal coordinator from there. Dr. Shivansh Mishra, who is from IIIT DM Jabalpur. Our resource people, Dr. Mustafizur Rahman and Dr. Ashwath, Dr. Anand Raman, who have joined. And it is time, as Saula sir mentioned, I'll request Dr. Kanaya Pandey sir to share a few words. Then I'll request Dr. Shivansh Mishra. Then my joint principal coordinator, Dr. Satyendra Singh Chauhan. He'll share a few words. Then we'll request the speakers to share, and then we'll go ahead with the first session of the day. Thank you so much, and thank you for the overwhelming response to this course. I hope you will be as sincere like last time, taking the course seriously, taking all the quizzes and attending all the lectures. This time the restriction is there, kindly note, 75% attendance, and of course last time also it was there 40% in the exams. So please take these two things seriously. This time I will be constrained not to release the certificates. We have released 930 certificates in the last course, QT-03. So we will try to do as best as possible. We try to help you, but you will have to fulfill these two requirements. Because National Quantum Mission, they have requested me to give the process. TCS also has requested, some of the participants are there, so they are also understanding how we are doing the course, and they want to evaluate, so that they want to give credit to these courses. AICTE, we have applied. Professor Vineet Saula is in touch with the AICTE officials, and we would want, as Sir has announced, after the 5 courses, we want the certificate to be issued. So all these things are going on. So please don't neglect the course. Don't just register and don't try to get the certificate. It won't come. Please attend the classes. Please take the quizzes, and please complete the course. We are very much happy to give you the best grades and give you the best support. And we will be with you as in the first 3 courses. So I'll request Dr. Kanai Pandey to take over. Thank you, sir.
Yeah, thank you very much. So I see that a lot of participants are already there, 535. And I was also seeing the schedule. Okay. So, and then the topic which will be covered. I think it's very well covered topics which is going to be addressed here. And it's very interesting that it is having a wide variety of topics. So for example, myself, I work in cold atom, but I'm going to attend other talks also, which will be given here to learn various platforms that how this quantum computation happens. Not only quantum computation, I see a lot of other part also. Yeah, so basically it's quantum computation only, sorry. And it will be very interesting to attend all the lectures. So I will request the participants to be attentive, and it is going to be very, very interesting, and you can learn a lot. Quantum computation is going to be the future. So we have to learn this subject very carefully and thorough. So it's very nice initiative, and thanks for inviting me for this session or whatever. But I'm going to attend the lectures also myself if I'm available. So thank you very much.
Yeah, thank you, sir. I'll request Dr. Shivansh Mishra to share a few words.
Hello. Good afternoon to all. Am I audible?
Yeah.
So, good afternoon, everyone. Good afternoon. I welcome the panelists as well as the participants here for this particular FDP QT-05. Most of the participants have some experience with the previous FDPs also, so I hope you will get good exposure to the quantum technologies. And I thank Professor Pilli sir, Professor Saula, for giving this opportunity. And I thank Professor Aprajita Oja for handling AICTE Academy from Jabalpur. Thank you, everyone. And I look forward to attending the sessions of this particular FDP. Thank you.
Thank you. Thank you so much. Dr. Shivansh was there all along in QT-03 and contributed a lot. And he's my coordinator, Dr. Kanaya. Dr. Satyan, are you able to join? Satyendra Singh Chauhan is assistant professor in MNIT Jaipur, Computer Science and Engineering Department. I think he's handling the queries of the thing, and when he's able to join, maybe towards the end we will have Dr. Mustafizur. PhD from IIT Kharagpur, Microsoft, in IBM Quantum R&D. Sir, over to you.
Yeah, thank you, sir, so much. Yeah, so first of all, thanks. I mean, for organizing this nice course. It's a huge effort, and I can remember, like on 31st May, probably almost 1.5 months back, Professor Vaswat approached me we are again organizing QT-05, and you can understand how much effort is there. And I requested him to gather as much as speaker this time, because every course when it is running, it is not just the participant who are learning, it is also the panelists who are also learning, right? So we are right now getting almost 10 speakers. So starting with Professor Ashwat Babu, Anindita Banerjee from SIDA, Ritojit from IBM, Professor Jines, Ananda Raman sir, Jai Kumar, and then Raghavendra sir, then Janani, Santosh, and of course Philly sir is there. So it's a huge effort, right? And QT-05, it's of course, the experience that all of you, what you gained from QT-01, QT-02, 3, and 4, that's a very good theoretical backbone of QT-05. And I hope in QT-05, you will be implementing a lot of things, all those knowledge acquired from physics, mathematics, computer science, all together, that you will apply on implementing algorithms on certain quantum hardwares that is available on Earth, right? And this is a huge course, and I'm very happy to take participation in this course. So thanks a lot. Yeah.
Yeah, thank you, Dr. Ashwat Babu. He is one of the IBM educator. He's assistant professor in IIIT Dharwad, Karnataka, and he's a PhD from IIT Kanpur. He's a specialist in quantum physics. He's writing the book on quantum computation for AICTE course. So this entire course curriculum, sir knows very well. He will give you a lot of written notes. So as you see, and handwritten notes, what I'm saying, both Mustafizur sir and even Dr. Ashwat, both of them, they share the written notes. For some of you who have joined now in this course itself, so you can go through. So all those who have registered for the first time, we will try to share the video links of the previous courses, so you can go through those courses also at leisure. Some of the talks the speakers may refer, we discussed in the previous course or we discussed in my last lecture. So please go back, and I will request the speakers also to refer maybe the kind of topic and ask them to refer to that videos. So we will share them. So now it's time for Dr. Ashwat to share the whole 10 speakers, putting them together. Dr. Ashwat played a main role. I thank him for coordinating on behalf of IBM. And also put in a lot of new speakers, and you will listen to all of them, and putting the content together in a sequence. We have speakers as Dr. Ashwat, Dr. Mustafizur already introduced, CDACT and Anutantra, which is a startup, and then so many people coming together. So I wish it will be a great learning, and continue to. There will be a packed 40 session course. So anybody, most of you faculty who want to take a quantum computation course in your college, so your 40 lectures, the slides, and sample assignments will be there. Coding, a lot of codes will be shared with you. A lot of Jupyter notebooks we have shared in the previous courses. So similar things you can expect in this course. So it's a ready-made course for you. If you want to offer from August 3rd onwards, you are ready. You can attend the full lectures and then start taking the course. Many of my friends who are part of the first 3 courses, they are all offering quantum course as an elective in their colleges. It gives me great pleasure and satisfaction that our efforts are actually multiplied. Mustafizur many times shares with me, it's a multiplicative effect that's going on. So let's hope that all the teachers who are here will benefit greatly, and you will all take up quantum course, either elective or minor, or whatever way you can, and help India gain this quantum expertise. And a quantum edge is the word that many times that's used. So over to Dr. Ashwin.
Very good afternoon to all of you, and very good afternoon to all the organizers for unending support and the efforts being put for organizing this AICTE FDP events. Yeah, Once again, I would like to express my gratitude to Pillai sir and Mani Madhukar sir, working behind the screen. Yeah, I think overall, I think this QT-05 would in a way would take the essence from the previous QTs and then put it here so that somebody who does this course, this particular FTP course, they can straight away go and introduce course on quantum computing in their colleges or the institutions. That was like Mustafir was referring earlier, and also Pillai sir also uttering the same. Yeah, so if you put some effort, I'm not even asking for 100% effort, some effort during the sessions and some of follow-up if you do, definitely you would have required a background to go ahead in teaching, right? So why I'm saying the moment you start teaching, you would get doubts in your head. Before going to class, you would get a doubt. So you clarify yourself first, and then you would get a chance to clarify the students. Whatever the queries they will be asking, there will be plenty with respect to this field. So you would have a second half of understanding when you start teaching. That's what happened with us. So like every day it is being learning. It's not like somebody become an expert in quantum computing. It's not going to happen. So it is like a ever ending process. It will keep going. Understanding would be keep developing. So the field is also advancing a lot technology wise, right? The theory wise it might be like saturated, but technology wise it is growing like anything. So many advancements are being happening. As of now, you can see the quantum computing, the immediate applications are in the case of secrecy, that's cryptography, quantum cryptography. Using quantum key distribution, secure communications could be possible, and people are already exploring in the line, right? And another immediate applications people are exploring from the quantum computing is this medical applications. Either you may take for using quantum machine learning for accelerating existing learning techniques. For example, in the case of studying the biological molecules like protein and so on, and then coming up with the drugs, the required drugs for treating them. So this is all like time-taking process with the conventional classical computers, but with the quantum computers, it is being accelerated like anything. So these are the two immediate applications, medical as well as security. So both are like very much immediate requirements for our well-being in the society. So quantum computing is able to offer both of them as of now. Okay, so there are many more applications which would come in future, but you can, as a quantum computing enthusiast, right, you can pose that quantum computing do have immediate applications, right? So yeah, not taking any much time, this is the inauguration program. So since I will be taking the next session, so we'll discuss much details as we go through the courses along the way. Thank you. I'll hand it over to Pillai sir. So thank you so much.
Thank you, Dr. Ashwath. Thank you so much. Yeah, Dr. Anand Raman is there with us from Nizer, Bhubaneswar. I request Dr. Anand Raman to share a few words.
Good afternoon, sir.
Yeah, please go ahead.
So, yeah, first of all, thank you for the committee members for giving an opportunity to learn and teach. Actually, it is a learning and teaching experience. So we are also, even we are the best student, I think. So while teaching each and every concept, we have to learn a lot. Yeah. So it is actually quantum, as Ashwath sir and Hajibur Rahman sir told, the learning is a never-ending process, and the best way of learning is teaching others. Thank you, sir. Thank you for giving me the opportunity.
Thank you, sir. Thank you for this time. Yeah, it's
Sir,
a joy again.
We have also started quantum course here at Jabalpur. Parihar sir, I think you remember him. Parihar sir was there, QT-1. So he,
Parihar, Ashish Parihar, yes.
So he's going to take quantum from August.
Yeah. QT-01 participants will be knowing Ashish Parihar was there. QT-02, I think. Yeah, QT-03, Shvansh Mishra is there from AIITM Jabalpur. He's continuing for QT-04. You have been interacting with Maipal Jadeja, then Vikash Kumar. Now this is Satyendra Singh Chauhan. He will be handling. His student is also there, Harshit Nema, and one more Jadon is there, and they will all be there to help you and assist you. They are part of the group. My student, Dr. Anand Mishra, is also there. He will be helping. There is a big support that is there. So please don't worry. Initially, there will be some issues. It's part of every course. So I am not worried. Please, you also don't worry. Tell your friends also not to worry. 1 or 2 days it will take. Till that time, let them continue on YouTube. Yeah, let me conclude this time because we're just coming to the end. We'll stick to the time. Started at 2 to 5. I lost, so maybe 2-3 minutes I'll take from Dr. Ashwath Babu. India is poised for a big move. And you heard of Quantum Valley, you heard of National Quantum Mission, you heard of quantum projects. I'll also extend your invitation to join a quantum discussion group, okay, which is another WhatsApp group, which is all the participants who have joined, they're willing to discuss. There are few people like Mr. Rajesh Chaurasia who put some questions for discussion. So there is a lively group. All the information I obviously share in all the 3 groups. QT-01, 02, 03, 3 groups are there. This is the QT-05, the 5th group is there. Of course, you will have different academies running their WhatsApp groups. There is a quantum discussion group. So I will share the link also. Most of you can join there as and when you find time. And accordingly, you can follow so many chats every day. So much of information Dr. Ashwath has just shared. Lot of awareness, lot of information, lot of material, many courses. I am also registered in 2-3 courses. You will be surprised. There is a Q inverse weekend courses going on. Few hours, just 1 or 2 hours every week. They want to share something on Q inverse. It's a simulator, right? So like that, there are a variety of courses which are going on, and many institutes, universities are approaching me also. Doing this. So, we are excited and involved in various programs, right? On July 19th, I will be sharing on quantum processors in a university in Andhra Pradesh, Rajahmundry. So like that, there are so many avenues and so much of information. So this is the right mode. I understand that the timings are slightly difficult. Quantum is difficult to capture. We can have 8-hour sessions, but it is very difficult. If you listen 8 hours, we'll be teaching 8 hours, no problem. But then 8 hours grasping is very difficult. 2 hours grasping is easy. Someday, maybe you may miss the lecture. Please, that day itself, spend 2 hours. I don't know where you will steal. Maybe in the evening. I have one colleague who says, sir, whenever I miss the lecture, I will not sleep till I complete the lecture. So she will sleep only after the lecture is heard. 2 hours is completed. So that the continuity and also the preparation is there, and writing exams will be easy, right? So little tough questions are there in few subjects. Dr. Mustafizur is one of them. So otherwise, by and large, the questions are moderate, and you can clear the quiz very easily. Quiz is more important. Attendance is also important. Of course, quiz is more important. But the is whenever you miss, once in a way, if you miss, please ensure that you will complete the syllabus. Only 2 hours. And this 20 days, please take it as mission mode. Otherwise, you cannot do it. And I have purchased a book. So some of these books are available, like this one, right? Introduction to Quantum Computing. So these books are there. Please purchase them. Please try to get. The author has shared the slides. Once the group is formed and slow interaction is happening, I will share the links. I will share the slides of this book, which he has kept it open on LinkedIn. If you find H.Y. Wong, you will find the slides and also the video lectures. So there is so much to learn, but collecting all the material won't help. Many people are asking me slides, no problem to share, but then you need to really read and spend time, right? Many people have joined this course from physics, electronics. Some of them are from biology. Some of them are from mechanical. Some of them are in management, but they want to learn and understand. And many of them are elder to me. So, and then they are learning from youngsters like us. Maybe in fact, Mustafizur and all, we are all young people, right? So, and they are very passionate. So I request the others who are maybe 30s and young faculty, please take it very seriously. Many of them are above 50 in this group, at least 100 of them. 400 of them at least are PhD holders. Just understand, not the teachers, the participants. So this is a wonderful opportunity. All those who did the 1, 2, 3 courses, they're excited. They're doing something or the other in quantum. And I wish that this QT-05 course also will be in the same way. QT-06, 7 and 8 courses are already planned. Professor Sahula sir has got the approval for 9 and 10 also. So we will continue the sequence. So maybe January, February, you will have those courses. So we'll complete that whole module, and all those who complete 5 courses will get the PG certificate. I request all of you to use this. At 500 rupees, nobody is giving this content. Please understand. I have been approached by few things. They want to offer a course. They say 80,000 rupees. I said, what are you doing? I am giving it for 500. They were also saying, yes, sir, I think that's okay. But this course has advantage. So see, at this rate, and IBM, any from IIIT, IIT, CDAC, all the people are sharing their resources, sharing the slides with you, and the notes is ready. So please take this seriously, and I wish you all the best. And I hope that we try to come up with recently had the privilege in summer June, I could visit the 25 qubit quantum computer physical in an organization called QPI AI. They were funded by the National Quantum Mission, Government of India, and they could set up in Bangalore. So I could see face to face a quantum computer. So it was such a joy. But someday, I hope that we will create a quantum processor in India. We will develop so many algorithms. Grover's algorithm. Grover is an Indian, but of course he must have worked abroad and got the algorithm. Some of the Indian universities will come up with good quantum algorithms, good quantum cryptography, good quantum key distribution. So I'm hoping, and that's my desire, that's my passion. Slowly, I also want to move away from administration and get into quantum in a very serious way. Hopefully, I'll be able to do that, and I wish all the best. So thank you so much for all those guests who have joined. IIT Roorkee, who is now serving as director of MNIT Jaipur, the AICTE funded by Ministry of Electronics, the academies, Professor Vineet Sahula, who is the chief investigator, and the chief investigators of other academies. From IIT Guwahati, it is Professor Gaurav Trivedi. From IIIT DM Jabalpur, it is Professor Aparajita Oja. From NIT Patna, we are missing Rajiv Arya, Dr. Rajiv Arya, who is the joint principal coordinator, but the chief investigator is Professor MP Singh, and others who are part of this great movement, and they have been great support to me and the team. I should acknowledge Dr. L. Venkat Subramaniam, who is the India quantum leader of IBM, and my friend, I would say Dr. Mani Madhukar. We were colleagues also for some time before he joined IBM. So that's where our friendship, couple of years, you can say, and the great team. He's a great support. He is not there, but he's behind the scenes. And thank you so much for all these people who are giving us this vision. Let's hope that we will get the best out of it. And for those who are just asking questions about the video recordings of QT-01, 02, 03, all the recordings are there. The link is given, which is a playlist link. So you will get the entire sequence of these 3 courses, and not only these 3 courses, the other courses also, maybe generative AI or medical imaging, other courses that have been done are also available. All videos are available as open source. Thank you for the vision of Professor Vineet Sahula, who says, let's give this content to everybody. We have taken permission from our speakers. They said, yes, please let the content go. I will share 1 or 2 lectures which Professor Mustafizur has shared to be shared with you. So those contents, last time course we have shared. So please understand that we all want to share. Now, only challenge is with you to grasp it and build it. So I wish you all the best, and thank you so much for joining. Thank you all the guests and speakers who joined for today. And it is time now to go for the session. I think we will end towards the last session on the Saturday, August 2nd. We'll have a farewell. That time we will have the speakers again coming back to us. We will give time and opportunity for some of you to share some of your thoughts. I have already seen the chat is already flooded. I will read through the chat while the lecture of Dr. Ashwath is going on. Thank you so much. I took 10 minutes of your time. Thank you so much. And it's a joy for me. And I'm always available. Dr. Satyan will be available on the WhatsApp groups. Your respective academies, I think Dr. Kanay Pandey, Dr. Shivansh Mishra, they will be, and their team will be helping those who registered with IIT Guwahati and IITDM Jabalpur. And I think one more, Spoke Institute of IIT Guwahati wanted to join. I'm not sure, there was some technical issue. So maybe tomorrow we'll give them some time to share with you, right? So it's a joy. Thank you so much. And over to Dr. Ashwath. Ashwath sir? Vineet sir, would you like to add something?
Yeah, Billy. I think we can go ahead with.
Yeah, we can go ahead. Yes. Sure. Yeah, Dr. Ashwath?
No, sir.
Yes.
So shall I take over?
Yes, sir, please.
Okay, thank you.
We will begin with the first lecture by Dr. Ashwath. Yes.
Thank you, sir. Thank you so much. Thank you, Shivansh sir, and others, Satyan sir, for the opportunity. Okay, I think we can start. Okay. So let me cut down my video. It might take too much of the bandwidth. Okay, so let me see if there are any questions in the chart. There are some questions in the chart I can see. Right. Basically, they are based on the previous QTs. Okay, so Pillai sir will take care of all those things and he will address those questions.
To the videos and other things. I'll answer them. Sir. So, yeah, please go ahead.
Yeah, don't worry. I can assure from our end, Pillai sir will answer each and everyone's question individually. So that much care sir will take. So that is assured. Okay, so yeah, anything related to audio? Any issue with audio from my end? So I'm speaking absolutely fine. Somebody saying thumbs up. Okay, no issues. Very good. Thank you. Okay, great. So yeah, okay, let me start sharing my screen first. All right. Okay, I guess you can see my screen. Okay, perfect. Right, so what I will do, let me present the brochure, what you have seen so far, right, while applying for this. Okay, as you can see, there's on the left, you have a team, the main backbone of this FTP. And on the right, what you can see, the resource persons list. So I am there in the first, and the other eminent people are followed. Okay, right. So those people will be covering few sessions and few 1 or 2 sessions also, depending on the area. Okay. So I saw a question by someone: is there a machine learning algorithms would be covered here? Okay. So let me assure you here, some introduction to quantum algorithms would be given. Okay, so let me give a brief about what is going to be covered. Okay, so let me enlarge this. Okay, just a minute. Yeah, you can see there is it's actually divided in a way into modules. The first module, what you can see, the spin-off systems and photon polarizations, trapped atoms and ions, artificial atoms using circuits. Okay, so what you see in the first module is introduction to the quantum information storage, right? So we need a means to store the information, particularly quantum information. How it is going to be done, that would be the main essence of this first module. Okay, so since first few sessions, okay, let me show you. I think this is the internal document. So, but anyway, to give a brief to you, okay, this is a tentative version. So this first session today, that is from 2:30 to 4:30, I would be taking. So the tomorrow also I would be taking from 2 to 4. And then the third day we have an invited session from Dr. Anindita Banerjee. Okay, she would give a brief over quantum advantage claims, whatever is there as of now, and what it can offer in the future. Okay, so the roadmap for future, she may take about an hour or so, and then I will continue whatever I left off in the second day, and I will start introduction to quantum gates. Okay, so that is the first part of introduction, right? So later on, we would go on to see some applications of quantum information storage, that is entanglement and so on. Those things would be covered in the second module. Okay. So coming back to the question somebody posed earlier, that is quantum machine learning is going to be covered in this module or not? That is a question posed. So let me try to answer that particular question. If you see here, this in a way it's a third module. Okay, so there is the introduction to quantum algorithms. Okay, so the quantum algorithm starts with the Dutch algorithm. So before that, before the Dutch algorithm, there is something called quantum teleportation and quantum parallelism. Okay, so those introductory preliminaries would be there. Those are not specifically mentioned here. So starting with them, people like our team would teach you people or introduce to you the Dutch algorithm and the Dutch Joyce algorithm. Okay, and these are like very fundamental level algorithms which would help you to understand how quantum algorithms work logically in the first place. Okay, and then followed by one interesting immediate application, which is Bernstein's Vajrani algorithm. So this is algorithm is actually introduced to quantum computing enthusiasts because this is the one which actually shows the power of quantum computing over classical computing. Okay, so you can easily show how quantum algorithms can outperform classical algorithms, and then followed by Simon algorithms. And the crown jewels of quantum algorithms are the Grover's algorithm and Shor's algorithm. Those things also will be covered. Okay, right? So what you can see, the very fundamental and kind of advanced application algorithms also taught. In the current existing quantum machine learning, the I would say like the workhorse of the quantum algorithms are variational quantum eigensolver and HHL algorithm. You would see what is the expansion later on, and QA-OA algorithm. So these like applied advanced algorithms would also be covered. Okay, so I would say in a way the basics of quantum machine learning algorithms would be covered in this particular FTP. Okay, and like I said in the inauguration, it is not going to be a complete. It is going to be still half done or a quarter done. You might need to do a lot of work or pursue further to become an expert in this area. But let me assure, whatever you would acquire through this FTP would really launch you to go further without any problem. Okay, and in the last module you can see there is an error correction. Okay, so there, as we saw, like most of you people are doing classical computing or came across quantum classical computing, there is something called errors, and addressing the errors or mitigating the errors is very much important. So those things, how we can do that kind of a mitigation in quantum computing, that is going to be addressed in the last module. Okay, right? So sometimes we might jump in between the modules, but whatever is promised in this brochure would be 100% covered in this particular FTP. Okay, right? So let me see, there is a question. Previous course contents are being placed as a MOOC to run as a course or issue certificate to participation. Video recordings are already available. Okay, this is from Pillai sir. Okay, sir. Yeah, Pillai sir is responding to the questions, and there is a group, WhatsApp group is going to be there. Okay, right? And you just be here. Okay. Yeah, is there any software you have to install? Right now, we are not doing any hands-on session through our FTP sessions. But let me tell you, there are speakers. They can show us some algorithms executed during the session, and they would inform you people what to be installed and how to run this particular algorithms or codes for you. Okay, right? So as of now, don't worry, sit back and concentrate whatever is going to be covered, and just give attention whatever is possible to acquire maximum. Okay, so any prerequisites required for this FTP? Right, I would say since I am starting at a very fundamental level, so if basic 11th and 12th standard basic physics is like chemistry, if we have gone through or recall, are able to just connect back to that basic physics level, you can easily go further. Okay, and also some mathematics. So all the engineering students, all the science students through their bachelor's and master's, they would go through a required mathematics. That is enough. Okay, right? So yeah, anything related to this QT-05, I would answer in the chat box. All other queries would be addressed by Pillai sir. So don't worry. All the charts being monitored. Okay. Right. So fine. So this is about our the content going to be covered in this entire 20-day sessions. Okay. So okay, let me get back how I am going to do. Okay, right? So I have created a folder, Google Drive, where I'll put all the lecture notes which I'm going to cover, and I will share that. And also, please remember, there will be a particular specific means for you people will be created. I think it's a Canva. So you will have an account there, and there's all the material from each speaker would be put there, and even your assignments would be conducted there. It is in a way like a Google Drive. Okay, and it's more one-on-one. Like say all the speakers can reach to you people through some announcement or through notes and all those things. Okay, right? So yeah, right. So whatever doubts you have, don't worry, all those things will be addressed. Okay, right? Fine. So let me start and go through. Okay. So I will present, like say, more like Pillai sir was already mentioning, I would use my presentations, okay, wherever needed, I would use. And more than that, it's not like a dumping a lot of information to you people, straight away presenting something that usually should be avoided, because it's not like a research talk. Like say, like 1 or 2 years research work is just like comprised to few slides, and that is being presented as a applied research presentation. So there it is fine, because people are assumed to have, this audience have all the background to understand those applied research results, and there is no need to discuss everything in detail. Okay, there presenting something would be straight away easy. Okay, but when it comes to this QTs, this quantum technology 01, so on up to 05, the main objective is to introduce the idea of quantum computing, the concepts of quantum computing to the faculties and postgraduates and undergraduates with full details as much as possible, so that you people get acquainted and perceive further. Okay, it's not like a movie or something you watch and enjoy and then leave it. It's not like that. You are going to perceive further. That's why I myself thought, instead of just presenting something like a presentation, wherever it's possible, let me do the presentation. Wherever it is needed, I would be using my hand notes, right? So which I write on a sheet of paper neatly, like a classroom running notes, which I would be sharing after the lecture notes. Okay, so that is the second way I would be communicating to you people. And the third, during the presentation or during the talking or describing something, I would prefer using some notebook where I could write something. You people can dynamically see what I'm writing, what I'm speaking. You can listen to, and if there is any doubts, you can ask too. Okay, so that is what I have planned. That was I will start doing from quite some time. It's succeeding, and there are no hiccups. If there are any, definitely we can address on the way. Okay, so that is how I am doing. And there are speakers, they will be doing on their comfortability or their level of convenience. Please cooperate. Okay, right? So fine, I hope you can see what I have written. Okay, right? So introduction to quantum computing, that's what I want to start today. Okay, so right, the question is, the number one question is, like always, for everything, okay, right, for everything, who is the main cause? Okay, right? Yeah, let me start my video if possible. Yeah, right. So who is the cause? Who led to this? Who is the lead to quantum computing? The first question. Okay, right? And see, for example, is somebody led to quantum computing? Okay, and first of all, why he led to quantum computing? That is the question. Why? Who and why? Okay, right? Obviously, for every technology to come up, there is a serious need, right? Okay, so what is that serious need? Okay, right? So let me give that serious need. What was it? Okay, so just take a simple example. Okay, let's say plants, right? So very simple example around us, right? So they survive. Okay, they survive based on the process photosynthesis. Okay, plants survive on photosynthesis. How? They take minerals from the ground, okay, and they take water Okay, and most importantly, they take energy from sunlight. Okay, they combine all of them and create the required nourishment, okay, or you say energy for the plants to survive. Okay, so that is what the process. Now, if you just cross check, some amount of sunlight it is going to take, okay, how much energy it is going to convert, how much, what is the conversion factor? If you ask what is a conversion factor, which is tremendous compared to what we humans are doing. Okay, so another thing is humans. You just take we humans, right? If we take a sunlight, convert that to, let's say, hot water, okay, heat. That is what through solar panels we are doing. Okay, or we can have some kind of a lighting mechanism, some solar lights. Okay, or we can convert that light into some storage, the solar sunlight into some storage units, the power storage to some batteries, whatever process you going to tie. Okay, if I just check what is the conversion ratio here, okay, if you check, which is going to be much smaller than whatever plants are doing. Okay, right? So much smaller. I will give one more less than symbol. So why this is? Because we don't know. Right? So back then we don't know. Let's say people don't know that time, so they want to figure out why is that so. Why is this discrepancy? Okay, so this is, let's say, before the birth of the quantum computing. Fine. So this is the time, okay, what happens? People start worrying or start exploring about how photosynthesis or how any biological process, takes place with a certain efficiency. Okay, very good efficiency, I would say, compared to we humans. The way our solar panels can convert the light into the required energy. Okay, right? So yeah, fine. So people started working on it. In the sense, whatever means they have, using that they were trying to work. So the best way to do is studying the previous literature, trying to understand how photosynthesis work, all those things they were doing. So one thing they were trying to do is use classical computing machines, whatever they have. Okay, using quantum computing machines, means classical computers, whatever they are, like in 1960s. Okay, around 1960s, at that time they started exploring or trying to study, let's say, biological process like photosynthesis using classical computing. Okay, so one problem there is, okay, let me give one description. Okay, one problem there is, if you just take just the photosynthesis itself, it consisting of so many parameters. Okay, so many parameters. Like say every process if you take, it relies on so many things. Okay, you take anything. For example, you are asked to join for a meeting. Okay, whether you are going for a meeting or not, it is controlled by or dictated by so many factors, whether you are available or not. Okay, whether you are having some other work or not during that time, or whether you have in the vicinity of the venue or not. Okay, So all the factors are there. All the factors, what happens, would dictate that process to takes place or not. So even in this particular case, okay, so for example, you just take a photosynthesis, right? Now, for a photosynthesis, okay, to takes place, there's so many factors are involved, okay? So much of factors, so many parameters, so many entities going to be involved, okay? So, too many, I'll say factors, too many variables means entities which are going to dictate, which are going to play. Let's say it's like a game of cricket. 11 players are there on one side, 11 players are on the other side. It's not like a tennis or something like individual games. Okay, right? And also the environment is involved, surrounding, right? So if you combine all of them, right, it is just a coupled, so many things coupled. Okay, what is that? If I just take an algebraic equation, for example, x plus y is equal to 5, there are two variables, one equation I can't solve. Let's say I have one more equation, x minus y is equal to, let's say, 1. Okay, so I would easily find what is the solution of this equation by solving this algebraic equation. So here, two variables, two unknowns. Okay, I can solve it easily, straightforward. I can use pen and paper and solve it. Solve easily. Okay, right? So I just take and I just add this equation. I'll get 2x is equal to 6, x is equal to 3, and I'll get y is equal to what? So 3 minus y is 1. So I'll have 1 is equal to 3 plus 1, that is equal to 4. Okay, am I right or wrong? Let me cross check. Okay, so I just took a random equation, x minus y is 1, x is 3, minus y is equal to here, and which implies y equal to 2. Very good. Okay, right? So I just simply solve this equation easily on paper. Very good. So let me take one more updated version of it. Let's say I have another variable, x plus y plus z is equal to, let's say, some 7. Okay, and say x minus y plus z is equal to some 8. I'm just taking roughly. I don't know whether they satisfy or not. Let's say there are 3 unknowns, 2 equations. I need one more equation. Let's say x plus y plus z. Let's say 5. Fine, it is easy now. I have 3 unknowns and 3 equations. Okay, and 3 equations. Very good. I can solve them straight away. Fine. Now, let's say I have 100 variables, x1 plus x2 and so on up to x100, corresponding to each variable. Let's say there is a constant, let me call C1, C2 and C100, which is equal to, let's say, some variable A, some value A, okay, which I don't know. And similarly, I have one more equation similar to like that. Okay, I'm just taking an example just to give you an idea what is multivariable system or multi-factor system. Okay, so I have only given 2 equations. So there are such equations. Let's say I have 100. Okay, another 100 equations downwards like this. Okay, so each equation has got 100 variables. Okay, such 100 equations are there, right? So here, if you recall back, this set of equations are solved using a matrix method. What is that? Is you write a matrix of coefficients, okay, which is multiplied by variables. is equal to the constants. Okay, which implies the variables is equal to, let's say, let me call this as a matrix, quotient matrix as C, which is equal to C inverse into 7, 8, and 5. So this is how I am going to find the solutions of this algebraic system of equations. But when you come back here, a large system where 1,000 by 1,000, sorry, 100 by 100 means 10,000 variables are there. Okay, 10,000 variables are there. And how should I solve that? So finding an inverse of an equation, inverse of a matrix C, which is, okay, I'm sorry, which is 3 by 3. Okay, 1 minute. This is going to happen. Okay, 3 by 3, a matrix C, 3 by 3 matrix. Finding its inverse is okay, I would say easy. Okay, let's say I have a matrix A which is of a dimension 100 by 100. Finding its inverse is very difficult. Okay, all right, which is depends on the capacity of our, depends on our computing machine. Okay, right, you see the things how become tough. Now when I take a photosynthesis, the dimension of A is so crazy. It is very, very large. Dimension is very large. Why? Because the factors involved in dictating whether photosynthesis to takes place in a particular order, okay, photosynthesis to take place in a particular order, there are so many factors are involved. Okay, so what happened now? People started, okay, let's use a classical computer and try to put all the factors into some set of mathematical model. Okay, some mathematical model. I'm just giving a description for, let's say, photosynthesis. Okay, so which definitely involves a lot of variables, lot of parameters. Okay, and they have come across a problem. Setting up mathematical model on paper is fine, right? I can just start writing equations like this. I was writing, I can write set of equations. Okay, so mathematical model involving equation 1 and 2 and so on, let's say up to equation some 10,000. I can write down that. But who is going to solve? Is it possible to solve it on paper? No, not possible. So it has to fed to a classical computer. Okay, now the problem is the classical computer is has its own issues. One is in 1960s, when the process of understanding this biological activity started. During then, that is the time I think computers, quantum classical computing, in a way it's advanced, very good, but the computing capability is limited. Computing capability is limited. Okay, why it is limited? The problem is storage. Okay, how much amount of storage is limited. Another one is processing. How quick you can store the information, but you should be able to process in much faster way so that you can go to the next solution or next equation and try to understand that also. So you need both. You need a processing, storage and processing. So both were very much limited in 1960. So it is like searching in the dark. Okay, what is searching in the dark is trying to solve or trying to understand the biological processes using a classical computers is, like, say you are searching in the dark. So every time they start, they are coming back to square one. Okay, so that is the time there is a nice, great physicist, I would say, and this guy, okay, let me show this guy. This guy came along. Okay, so in fact, in 1960 itself, he hinted an idea to start computing or doing computation on a device which is actually suits for that particular process. Okay, right? What do you mean by that statement is, let's say classical computers, whatever they chose, right, whatever existing, they're based on some principles which are suited for some processes. Macroscopic process means large entities, large. Let's say I want to calculate how a projectile is traveling. If something is thrown with certain velocity, certain angle, how it is traveling. If there is a wind flow, what is the effect? Such things, the macroscopic events could be studied. But when I go to microscopic tiny level, so like photosynthesis, in that case, the machines, the computing machines were unable to process, unable to understand, or unable to let somebody to understand. So that is the time he hinted, you better come up with a machine which is going to incorporate the idea of microdynamics. Okay, so that is what my first statement in this slide. He hinted an idea of using quantum effects to realize a computation. Okay, that is that. Maybe he might have uttered or somewhere in a talk he had, but the actual description of his full-fledged idea, he gave a talk in 1980, and also, okay, it's eventually circulated among the community. So where he said, whatever computers which you have, classical computers which you have as of now, if you are trying to use them to study a photosynthesis kind of a process, you are not going to succeed, because these machines are, in a way, is not incorporating or addressing the effects of micro entities or microdynamics, because these machines were devised or described or designed based on macroscopic events. Okay, right? So let me put that into the notes. So the classical computers were based on macroscopic dynamics. I'll come to that. What is that macroscopic? I'll explain. Okay, right. Wait a minute. So if somebody has a doubt, you can ask related to this. As per the instruction, by the chance we have attended. Okay. Where we can expand storage and memory parallelly. Okay, so yeah, so some generic, not generic, advanced questions are being asked. We'll come to that at some point. So let's continue. Whatever, like where we are at, related to that, we will try to cover. Okay, right? So the macroscopic dynamics, I'm going to based on macroscopic dynamics. Okay, so classical computers were like that. Then he said, you use a computers, or he called machines, which were constructed based on microscopic dynamics. Okay, microscopic dynamics. He said that you better design or come up with a quantum computers which were based on microscopic, means very, very tiny. Macro means large. The classical world, whatever world we are existing in, that is a classical world. Okay, so please explain macroscopic and microscopic. Okay, fine. So let me explain that. So micro means, okay, let's try to come up with the macro and then go down to macro. Okay, so macro means the real world where we are existing. Okay, and let's say if I just pick my phone, this is a classical object, real world object, where I can touch and feel and pick it up and see. Okay, right? So this is a classical world. Right? And easy way to describe this is, suppose if I have left my phone on my table, it exists there unless somebody comes and going to disturb that. Okay, so that is a classical word for you, and it is called inertia of rest. Okay, let's say an object which is traveling, okay, unless something goes and disturb that object, it keeps traveling. Let's say I throw an object like a ball. If I just throw a ball, it just takes a projectile. If I just throw a ball with certain angle from the ground and with certain initial velocity, it travels and falls down. Like earlier I just said, it has to travel, keep on traveling because nobody disturbs. No, there is a gravity which is keeps acting on this thrown object because of the, even though I have given some energy, some velocity, it travels and attains some height. After that, it falls down. So during the travel, it is in the inertia of motion because of gravitational pull or force downwards. This projectile is falling down. Okay, so for time being, it is existing in moment inertia of motion. After that, it comes back to inertia of rest. Okay, so who described it? It is a real world fact. Who described? Newton actually gave a very nice set of equations. Those things would describe this real world activities like dynamics. First, he said, if anything which exists in the inertia, means inability to change its position, inability to change its motion until somebody comes and disturb, it is called inertia, equation of inertia. Okay, so that is first he said it's a law or it's a fact. Okay, and he gave another law, Newton's second law. What is that says? If there is a force acting on an object, let's say F, let's say I have a table. If I put a force on the table, let's say mass of the table is A, it gets moved with an acceleration. Okay, so the table is there. I am going to push with some force. The table mass is m. It is going to attain an acceleration a. So force and acceleration are connected, in fact. And how much acceleration is dictated by the mass? Mass is like a resistance to a work. Okay, so it's a directional proportionality. You see, is actually dictated by a mass. If the mass is more, acceleration is obviously less. Okay, you see, I can't push a table with a very great acceleration, right? So depending on the weight, the table is huge. I can't move at all. Okay, acceleration always going to be small. Okay, fine. So this is second law. And another law he gave is, like everybody remembers, action is equal to reaction. So let's say there is a rocket. If the exhaust is coming down, okay, so rocket would always go up. So there is a reaction force downwards, sorry, action downwards, reaction is upwards. And he said that always the action is equal to reaction. That is the third law for you. So this is a basic Newtonian laws. Okay, so anything which obeys this Newtonian laws, or let's say other way around, because this is Newtonian laws came later, nature exists before. So let's say anything which is described by Newtonian laws is a classical world, is a macroscopic world. Okay, right? So that is a distinction for you. You just take a Newton's laws of motion, or Newton's laws of inertia, or Newton's laws of action equal to reaction. If you can explain every dynamics acting in that zone or a domain, if Newton's laws is succeed in explaining, fine, you can just distinguish or describe that as a macroscopic world. Okay, right, let's put this aside. What is the other one? What is a microscopic? Right, very simple. You say if the Newton's laws fails to describe, right, their dynamics, right, if they fails to describe, straight away that is a macroscopic world or macroscopic domain, right? Okay, so I gave you a statement. How to understand that statement in a real world? Very simple. Okay, so micro means small, as you guys know, we are microscopes, right? So let's say this is a macroscopic object. It's a huge, I can touch and feel and see. Let's say I have an atom, a single atom. Like I just take an object, knock, let's say if I just take a pen, right? Okay, I just knock a small entity from it. How small? A single atom. Okay, if I just knock a single atom out of it and take, let's say I'm able to hold it, let's say assume it, right? I'm able to hold that atom. Let's say I'm going to keep it on my table. Okay, right? So let me assure you, in this case, it is possible experimentally. People are doing it. People are able to knock a particular single atom out of an entity, or even they can knock a subatomic particle like electron out of it and hold it and keep it at some point. Okay, so let's say take an atom or an electron. Okay, take that. And let's say I'm just able to keep it on a table. Okay, right? So atom has got a mass. Let's say electron has got a mass. Fine. Okay, right? So as per my Newtonian understanding, Newtonian laws of understanding, I'll take the electron and keep it on a table. Let's say electron is put it on a table. So, right, I don't use any theory, but I am just an experimentalist per se. I'll take an electron, keep it on a table. Okay, so I'll just start observing the electron. Now, as per my understanding of Newtonian laws, unless somebody comes and disturbs this electron, it has to stay on the table without being disturbed, because it is in the inertia of rest. It is inability to change its position, because nobody is giving any action on it, nobody is giving energy. That is what my perception, that is what my real world understanding, classical world understanding. Okay, if I start observing that electron, if you make an observations, okay, if you make observation on that electron, there is a very interesting observations you would be getting. What is that is, okay, number one, electron is not stable. Okay, means it is not staying in one point. Fine, we'll try to understand that later. Okay, what else? Okay, let's say I just confine the electron in a box, right? And I just switch off the temperature. Means, let's say temperature is the main means to give the energy to any entities. We are existing in room temperature, 27 degrees Celsius around. That is very much required to our metabolism. Even though our body temperature is around 37 degrees Celsius, we need 27 degrees Celsius, or even we can work up to 40-45 degrees Celsius temperature. Okay, right? Let's say temperature goes to sub-zero. So we have to maintain our temperature from 0 to 37, right? Because of that, we consume a lot of energy. If it's the temperature around me is just 27 degrees Celsius, to maintain my body temperature from 27 to 37 is less energy consuming. So I would require less amount of energy. Okay, fine. So when the electron is in the room temperature, let's say room temperature is giving some energy to the electron. Because of that, if I assume it is moving around, so I want to remove that room temperature. Let's say I'll put a box, very, very strong insulating box. And I'll ensure that the inside the box temperature is 0. Okay. And second observation, let's say I'll make 0 degrees Celsius. What is the temperature? Okay. 0 degrees temperature is there. When I make observation again, even in that electron is not stable, even at 0 degrees Celsius, absolute 0 case. Interesting. Let's say the temperature is not giving any energy. That means somebody else is giving the energy. Okay. Let me do one more experiment or extend the experiment. What I'll do, I create a vacuum. Means maybe there are some air particles which is giving the energy to the electron. Because of that, it is not going to be stable. So let me vacuum, remove it, completely remove. A vacuum means you suck every air particle inside and ensure that the only box, anything which is consistent inside the box is just the electron. Okay. So if that is the case, if you see now, in that case, let's make an observation on the electron. Even in that case, electron is not stable. Even with the vacuum. Okay. Interesting. Why is that so? There is no entity which gives the energy to the electron, but it still goes here and there as if, let me give a counter example or the descriptive example. Let's treat this as an electron. The phone which I'm holding in my hand is electron. If I am just placing on my table, as if phone goes here and there and just making just movement here and there, that is what I'm observing. My phone is going everywhere. You are going to agree such scenario? No, absolutely no. I'll not agree. My phone will stay stable because it's a macroscopic object. But when I do the same experiment at a microscopic, the phone, like an electron, goes here and there, makes jumps here and there, and it is not stable even though somebody is not giving any energy. So they say there is some energy associated with that particle and energy system electron. It's called 0-point energy. Okay, it has 0-point energy. We'll come to that. What is that 0-point energy in detail as we go through these sessions. For the time being, you just take it for granted energy comes from nothing. Our electron has its own internal energy before even you are placing there, right? There is impossible to remove that internal energy. However amount of cooling I do, I cannot remove it. That is the 0-point energy for you. Because of that 0-point energy, electron goes here and there. The Newtonian mechanics or Newtonian laws of physics never addresses that. Because Newtonian mechanics, straight away the first law says inertia of motion, inertia of rest. Doesn't bother about whether there is a 0-point energy or not. Okay. So in the macroscopic domain or a macroscopic world, the first thing is Newtonian laws fails to explain. Okay. Right. Now I hope you know how to distinguish between macroscopic world and microscopic world. Okay. So the macroscopic world, you would need a new laws of physics to describe that or to explain that. But macroscopic world, straight away we have Newtonian mechanics. Other laws based on Newtonian mechanics people have derived. Using them, you can all explain every process. Okay. Right. I hope I made things clear here. Right. Somebody was saying they were not able to see the screen. I'm also running another device where I can see what you people are seeing. Okay. So I am not sure if there is an issue with you. Please go and check. Right. So yeah, others are saying it's fine. Okay. Now, those who were asked that question, I hope it's fine. Understood what is a macroscopic world and microscopic. Let's get back. Why did we come across this? Okay. So people were trying to understand the activities which are taking place at the macroscopic world. Okay, at the macroscopic world is a photosynthesis process. So at the macroscopic world, actually the atoms are electrons which are traveling and molecules which are traveling, and they're going to do some task which is a perfect task. Okay, so people are trying to understand that. People to understand that there are so many parameters involved. So to incorporate, to address or tag all the parameters and see what is the effect of one on the other and so on, we have to understand that, right? So for that, classical computers are not going to help them. So quantum computers are the ones which are going to help them. So for the time being, let's not say that quantum computers are there yet. So now we are trying to get into that with the introduction. Okay, so that is the time this gentleman, he hinted you better start using machines which are going to address the microscopic events or microscopic dynamics. So in a way, we could say that he is the father of quantum computing. He has actually given a spark towards quantum computing. Okay, right? So the next thing is somebody has to follow it up with his idea. Okay, right? So now the question is why? Why somebody has to follow it up? Okay, so let me give a simple example. Okay, for example, let's say I have to say travel between city A to city B. Okay, so there is multiple paths. Okay, so as of now, I'm just drawing only 4 paths. If I ask what is the best path, straight away I'll pick the shortest is the best path because it consumes less time, okay, and also consumes a less resource, obviously. Let's say there is a traffic, too much traffic in this particular path, okay, and I have to start and stop and start and stop and start. Because of that, I take a lot of resource or fuel, and also I consume a lot of time. So in that case, I will look for an alternative route where there is a less traffic but less distance. Okay, for that I need a information of what is the traffic, what is the distance. Okay, so let's say there is another parameter here. What is that parameter is? Let's say there is a serious raining in this road. Okay, and road has some issues. Okay, even though traffic is less, there is some issues with the road and the weather. So I will go for another route. And again, I will check with this particular route. Okay, and if there is any dictating parameters which going to tell me whether my path from A to B is less time taking or less resource taking. So similarly, I will also explore another route. Okay, so out of all the 4, I would come up with the best option. How do I do? Probably I'll do myself traveling before, or I will seek help from somebody else. Okay, and I'll seek somebody else information, and from there I figure it out what is the best path. Okay, right? Now the question is, there are only 4 paths. I can easily go to nearby people who travel often. I'll ask them and find out what is the best. It's fine. Or let's say no one is there to help me. Let's say I want to do multiple trips between A and B. What I'll do? So I'll figure it out what is the best path for my later travels, and I'll just choose that. Okay. But the thing is, let's say I have 1,000 number of paths. Okay, that time I can't do myself because it itself consumes a lot of energy. Okay, right? So I have to seek somebody's help. Let's say somebody is there to help me. Okay, so 1,000 path information somebody is given. Somebody says there are issues in the road, weather is sometime like this, there is a traffic, something like this. They'll give all the numbers. Okay, so in that case, I have to put them into some kind of a matrix or something. I have to find out what is the best out of it. Okay, so there is a best out of it, something like this. I have to choose that. Now it becomes a mathematical problem. Okay, now out of all the possible routes, choosing the best is a mathematical problem, or finding a solution to a mathematical set of equations, or finding a matrix eigenvalues and so on. Okay, so that is there. Now when it comes to photosynthesis, let's say plants achieves 100% efficiency conversion, right? Very good efficiency. I'm just giving exaggerated number. So let's say we humans dwell around 20% humans efficiency, energy conversion, humans and plants. Okay, and why is that so? The question is very simple. Humans' ability to process the information is very much limited. They need machines to do that because we exist in the classical world, the real world. But when it comes to plants, okay, so in the case of plants, let's say there is a path to achieve 100% accuracy, 100% efficiency. Okay, so there is a, let's say 0% efficiency. From 0 to 100, there are paths. Okay, right? So reaching 100% efficiency in much shorter time, okay, quick time, plant somehow knows it. But when it comes to us, we can't reach 100%, forget about it. We will just stuck at 20% or close to 20 to 60%. Why is that? Because the number of paths which are required to figure out to reach 100% are there in billions or in trillions. There are so many paths, but even the same situation here, but our computing ability is limited and our advanced technology is limited. We could only achieve certain limited amount of efficiency. Strange how plants are doing? Very, very simple. They work like quantum computers. Plants work like quantum computers. They don't have any machines inside. This is based on quantum principles. They work based on quantum physics principles. Let me put more descriptive physics principles. Okay, somebody who follows basic physics, quantum physics principle, not basic physics, quantum physics principles, so they could able to explore large amount of data, large amount of paths in much more quick time compared to we humans. That's why a photosynthesis can happen in no time, just like that, with high accuracy. But we humans were trying to mimic the same process using solar panels. So solar panels, depending on how advanced, how expensive panels are, you might go something like 60 to 70 at the most. Okay, right? We are not reaching 100%. So always there is a wastage. That is because our inability to do that. So, right? So that is the time, if you start using quantum computer, we can try to understand how plants are doing. People are trying to study that. Okay, so Richard Feynman gave the idea, and then it's followed up by this person. His name is David Deutsch. Okay, right? So he took the idea of Richard Feynman. He followed it up with saying, okay, I'll devise or I will design a mathematical model which addresses quantum physics principles. Okay, so that mathematical model would like at least solve few things, at least address few things at a microscopic level. Okay, it's just to design a mathematical model. So he said it is something like a quantum Turing machine. Sorry, it's something like a Turing machine. So it is like in a way analog Turing machine. We call it as a quantum Turing machine. Okay, so what it does is it model based on two-state system, okay, that evolve under certain operations. Okay, two-state system means if I just take anything which exists in one form, the other form. Okay, for example, you just take a water, if I boil it, it becomes a vapor, another state. Or take a water, you can like cool it condenses to become a ice. So another form. So mathematical model which is addressing is a two-state system which evolves between these two states based on some operations. So that is the basic idea he took at microscopic level or macroscopic physics-based idea, and he like followed it up. Okay, right? And one interesting thing he showed is, like I showed it, like mentioned in the last statement, if I use that such machine which could simulate any physical system much faster than a classical computer. That's the first impression of the idea of Richard Feynman. Okay, right? So very good, fine. So the idea is carried along. Now I have to use that idea for an application. So for that, the Richard Joyce came and he started working with David Deutsch, and they together came up with an algorithm or a set of commands which can make this mathematical model to do some calculation and give some results. Okay, so all together, okay, so the altogether the objective is to understand the tiny processes. For that, David Deutsch designed a mathematical model, and Richard Joyce came along. Let's say he said, okay, we have to do this way, this is a command, this is the step, first step, second step, and so on. So if you follow this set of commands and algorithm, this is going to give us very good results. Okay, what is that result is? It can become very, very fast. Okay, and it can become more accurate in comparison to existing classical computation. And see, whatever these guys were figuring out in 1992, followed by the Bernstein and Vajjani, and they showed that these are significantly faster. This machine or this model and this algorithm is significantly faster. And another scientist by name Daniel Simon showed that it has got exponential speed up. Okay, and it is possible. That is what he showed. Fine. So we'll take it for as a fact. Now, what else growth-wise quantum computing? The next thing is, in a way, like a blow to the existing classical computing given by this greatest physicist, I would say, or mathematical physicist, Peter Shor. In 1994, he gave an algorithm, okay, it's called Shor's algorithm, which can work on a quantum computer. Okay, so this algorithm, the power of this algorithm is, see, existing our communication, whatever we do on internet or a classical communication channel, whatever existing, it is secured by RSA encryption. Okay, classical internet or communication is secured by RSA encryption. Okay, right? So what is this RSA encryption? Let me give in a nutshell, right? So it is based on some key, a secret key. If you know the secret key, like a password, you can log into a particular account. Okay, right? So let's say I want to have a key, nobody else can find it. Let's say I have a key, keyword for my login ID. Let's say word physics. This is my keyword, right? How many letters are there? There are 7 letters. So 7 letters are there, alphabets, by the way. So somebody can start figuring out what is the keyword, like a password of my particular account. So what he can do, he can start with the first letter. He can start with the A to Z, 26 letters. He can exactly stop at P, and somehow using classical computing, you can figure it out. Okay, so a simple blind way of putting a password physics is not going to secure. So what they came, so RSA encryption is, they took a very large prime number. Okay, right? If I just give a prime number, let's say 49. If I ask what is the factors, you would guess, you would give straight away. Let's say a number 81. If I ask what is the factors, you would get a 9 into 9. If I give a large number, let's say 8, 5, 6, 7, so on, let's say some 1 at the end. If I ask what is the prime factors of this number, fine, you would feed this number to a calculator or a machine, a quantum classical machine. I would figure out what are the factors. Let's say this is n. You would find what is factors r and p to that. Okay. Let's say your computer cannot do that, or your machine cannot do that. Okay. So then you will be unable to find the factors. So those factors are used to create a key, that is RSA encryption. They took a large prime number, and the factors of that large prime number were the RSA encryption keys. Okay. First of all, if I have a number, how can I find the factors? It's difficult for any machine, right? So what I can do other way around. Take two large prime numbers, R and P, large primes, multiply. Okay. Multiply them. And I will get n. Okay, I'll give R and P to somebody who wants to communicate with me. Secretly I'll give, and I'll keep n with me, and I'll tell him, you go somewhere else where I can't see. When you make a call, let's say I can't recognize your voice, you please tell me what is the R and P. I'll take R and P. He will give two numbers. I don't know if this is R and P. I'll just he will just give some X and Y. I multiply, and I will see whether some number C is coming, whether it is equal to n or not. If I find it's equal, oh, I recognize, yeah, this is a person to whom I have given my keys, R and P, and I'll say, yes, I am recognizing you. We can start doing communication or transactions, whatever we want to do. Okay, that is how banks working, right? So this RSA encryption is based on the factoring technique. Okay, means the factors are there in the public. Okay, and the right factors are only going to allow you to connect to a server. So that is what the RSA encryption. Okay, now the n is known, but finding R and P is not possible. Okay, so that was the security for us. Now n is there everywhere. A very large prime number is there everywhere. Only R and P is not there. Okay, so if I happen to have a quantum computer with a quantum computer, okay, so quantum computer usually dictated or let's say specified by certain specifications, right? Let's say there's something called qubits. You heard about it. So the number of qubits, let's say I have 10,000 qubits. Perfect qubits, by the way. If I have 10,000 qubits, and the Shor's algorithm means he has given a set of steps, that is Shor's algorithm, on this device is going to break RSA encryption. Means whatever n large prime number is there as a security in the community, communication community, it is going to be factored in no time if I have 10,000 number of perfect qubits in my quantum system.
Sorry.
Okay, right?
Can you please, sir?
Sorry.
Can you please give a break of 5 minutes? We'll change the YouTube.
Oh yeah. I'm sorry. I forgot. Okay, so we can have a break now. We will come back at 4 o'clock. Okay. Yeah. Thanks for reminding, ma'am. Yeah. Let's have a break for 5 to 6 minutes, or maybe 10 minutes or so. We'll come at 6:05 sharp. Okay. Thank you.